to start.
So welcome you all to our 5th webinar. We have within this cycle, we have another one, the 6th on the 26th. You are more than welcome to join us on that date at the same hour, 1400 hours PT time. And today we have two invited guests that I'm very pleased to have with us. Professor Michel Duri from Nicosia University and Professor Thanos from Aristotle University of Thessaloniki in Greece. So we are more than pleased to welcome you all and for you to be able to share with us some more knowledge regarding air quality and other related issues that are very interesting. This is indeed being a good run for me personally, because I did not know that much about these issues, and it is very, very good for me in terms of learning all the knowledge that you are willing to share with us. So I'm going to pass the word to Edna, that is going to present the first speaker. Edna, please.
Yeah. So good morning or good afternoon to everybody from Cyprus. Our speaker today is Mrs. Michel Duri. Michel has a BSc in Mechanical Engineering, a Master's and MSc in Sustainable Energy from the Frederick University in Cyprus. And she's currently a doctoral student in the Oil, Gas, and Energy Engineering program here at the University of Nicosia. Yeah. Her PhD research focuses on pollutant emissions of the transportation sector and their impact on public health, which is also the topic of her presentation to us today. So Michel has participated in workshops on remote sensing for climate change management and aerosol analysis. She has used GIS, Geographic Information Systems, to digitize the map of Cyprus. And she also has worked in Horizon 2020 projects, integrating Internet of Things and smart technologies to enhance building energy performance. Yeah. So without any further ado, so Michel, if you could go ahead and start your presentation.
Thank you very much, Edna, for the introduction. I'll be happy.
It's very low. If you may need to speak louder or increase more of your volume.
All right, just as we discussed. Thank you for your introduction, Edna. I'm very happy to share my presentation with you all here. I hope my volume is now audible for everybody. Okay,
yes,
so
I think so.
Okay, that's great. This presentation is on the vehicle exhaust emissions that we have in Cyprus and the effects on respiratory and cardiovascular health specifically. So it is structured as the first slide showing the problem definition of the project and the aims. We will go over the methodology and we will look at the results. So first of all, the problem definition includes investigating the primary and secondary traffic-related emissions on our chosen health outcomes. And these health outcomes were chosen because they are the most affected by the traffic emissions in an urban environment. We will be focusing on Cyprus's fleet, which has a unique combination of aging passenger cars. We have a very old fleet of diesel passenger cars compared to the rest of the EU. And we also have the largest share of petrol passenger cars in the EU, which gives us a very unique cocktail of emissions because of the fuels used. And we will also be focusing on PM 2.5 and 10, NOx, SO2, and ozone concentrations. We're going to look at the lockdown period because it gives us a unique year, although we're focusing on a 2.5-month period, which was the first phase of the lockdown. It gives us a unique insight into what life is like with reduced mobility from vehicles, reduced and restricted economic and industrial activity as well, allowing us to decouple some of the pollutants that we measure in the urban areas. So I've talked about some of our aims, which is to pinpoint the sources of pollution, especially the high polluters from our vehicle fleet. We're going to look at secondary aerosol formation, which is as a result of traffic emissions, primary traffic emissions. We're going to investigate that on cardiovascular and respiratory mortality rates as discussed. So first of all, we looked at the national emissions inventory over a few years, 2020, which was the COVID year, 2019 pre-COVID, 2021 COVID. And if we just zoom into the pie chart, we can see how the emissions are distributed from the different pollutants that we have. We can see a drop during 2020, which is the orange bar chart for most of the sectors. And road transport in 2021 made up 33% of the national total sector emissions. When we look at the fleet of Cyprus passenger cars in Cyprus in 2021, we can see that a large majority of them are petrol passenger cars. So Euro 3 and 4, which are aged between 12 and 20 years, which is already quite old, they make up 32% of the entire fleet. This includes your motorbikes, heavy-duty vehicles, and the like. And VOCs from petrol, specifically aromatic VOCs, form 30 to 70% of the PM2.5 that we measure at the urban stations in cities. We can also see the trend of the vehicle fleets from 2023 to 2021. And we can see for the diesel passenger vehicles, we can see that as we approach 2021, we are increasing the proportion of Euro 6 and newer vehicles, which is very good in terms of emissions. And then for petrol vehicles, we can see that the majority of vehicles remain in this mid-range of Euro 3 and 4. We're going to look at the methodologies covered in the study. We considered 2 cities in Nicosia, in Cyprus, the capital, Nicosia, and Limassol. We also used the background station in Ayamarina that has some air pollution concentration data. So first of all, we collected traffic volume data from 6 stations in Nicosia, which are shown as the red lines in the map below. We looked at their results plotted on a weekly timeline. If you look at the plot for 2019, 2020, and 2021, and we can establish that there was a reduction in traffic volume during the 2.5-month period, which is from the 1st of March to the 31st of May, when the lockdown restrictions were eased. We also looked at the health monitoring unit data, which gave us statistics on a city level of respiratory, cardiovascular, and total deaths in Nicosia and Limassol. What we see here is the analysis of pre, during, and post-COVID. The first graph shows us the emissions in 2020, with baseline 2019, and we can see that we have a reduction for all vehicles over all the pollutants, except for light-duty vehicles, which leads us to see that light-duty vehicles were some of the few vehicles allowed to continue with their transport during the COVID period. And then moving forward to 2021 with baseline 2020, we can see that after COVID, there was an increase in mobility from all the vehicles, as well as an increase in the associated pollutant emissions. We have the highest reductions during 2020 from motorcycles, heavy-duty vehicles, and buses. And then we also see that from this, we have a 61% reduction in non-methane VOCs. Now, we're interested in non-methane VOCs because they drive the secondary aerosol formation. Then post-COVID, we can see we have the largest increases for motorbikes, up to 150% for PM2.5. We also have increases in VOCs because motorbikes emit larger amounts of VOCs than passenger vehicles. And this has been detrimental to the air quality in the city. Now we're going to look at the methodology for calculating primary and estimating secondary pollutants. We are using exhaust emission factors, and these are given in the COPERT methodology adopted by the European Union for calculating emissions from the national traffic fleets. These are based on vehicle speed from arteries and roadways. We also have mileage that is given by the statistical service, where we use an average annual mileage. We also have some assumptions when we use this program of mileage degradation, where we assign a lower annual mileage to older vehicles, given that this is what actually reflects real world situations, where older vehicles are driven much less than the newer vehicles, so that we don't skew results. Then for the secondary formation estimation, we considered in literature different emission factors for secondary organic aerosols and also secondary inorganic aerosols. They are given in two forms, grams per kilometer and also grams per kg of fuel. In this presentation, we're going to look at the results from emission factors using grams per kg of fuel, because it also gives us a way to validate our results by comparing with the statistics of fuel sales, both petrol and diesel, for a specific period in time. The methodology for calculating premature deaths is based on a relative risk of exposure to the PM pollutants, NOx, NO2, ozone, and SO2. The population considered in the study is 30 years and older, and this is our threshold, given that the symptoms that would cause premature death are more likely to be applicable to a population of 30 and over, both for men and women. So looking at our results, we're going to start looking at the lockdown period to see if we did indeed have any reductions in pollution from vehicles. And we can see here that the yellow space shows us the reduction using the trapezium rule. We were able to calculate the reduction in terms of percentage compared to 2019 levels. And we can see that for NOx, there was an 86% average reduction over the 2.5-month period. for PM 2.5, we have a 16.2% reduction. Although we do not exceed the World Health Organization or the EPA 24-hour limits, we do notice some spikes that we're going to look at in the next slide. So the spikes that we see in PM 2.5 graphs, they show dust episodes, as this is a springtime period, and the Eastern Mediterranean, where Cyprus is situated, is prone to dust storms during this time. And what we did to ensure the source of the elevated PM 2.5 was to look at a back trajectory of Cyprus during this period on the 18th of May. And we can see that dust is traveling from Turkey towards Cyprus, bringing in this transboundary dust. We're interested in transboundary dust because it affects secondary aerosols by providing nucleation sites where VOCs that have been oxidized can condense onto these smaller dust particles, growing larger and adding to the PM 2.5 mass that we measure in our atmosphere, in our measuring stations. Next, we're going to look at traffic volume. We have 6 roads in Nicosia, namely Spirou Kyprianou Avenue, Prodromou, Krivadigeni, Strovolou, Seriou, and Athalasas, and these are mostly in the center, as we saw in the map at the beginning of this presentation. The lowest reduction during the lockdown was Athalasas, which only experienced a 13%, and given its location, this shows a continuation of vehicles traveling at an intercity level. And then on the second slide, on the second graph on the right of the slide, we look at traffic volume in Krivadigeni, which is a main road in the capital, compared to 2020 and 2021. So our baseline is 2019, and we can see the biggest reduction was during 2020, during the lockdown period, and the NOx levels are the gray line, and we can see that they follow very closely the trend of traffic during the lockdown period. Our results for secondary emissions after applying the secondary production factors are shown in the 2 graphs below. We were able to plot the official PM 2.5 emissions from traffic given in the national inventory and plot them against the PM 2.5 that we have attributed as being secondary. And we can see that though we have decreases in PM 2.5 due to the introduction of stricter Euro class regulations on pollutants, we have an increase in secondary organic aerosol. And this can be due to the increase in the vehicle fleet. We also have an increasing diesel passenger car fleet, and these contribute to secondary organic aerosol concentration because of their large concentration of intermediate VOCs in diesel fuel. And then when we look at the proportion of primary emissions and secondary emissions, we can see that in 2021, primary PM 2.5 made up 56% of total PM 2.5 emissions. Petrol made up 5%, and diesel secondary organic aerosols made up 39%. In total, that's 44% from secondary emissions, which is quite substantial, and it affects our public health as well. Now we're going to look at how it affects our public health by looking at the total deaths. And in this graph, we have Nicosia and Limassol deaths attributed to all the pollutants from traffic. More specifically, we will look at respiratory mortality in Nicosia. And what we have here are deaths from NO2 on the left and deaths from PM2.5 on the right. We can see that the deaths for NO2 are much higher than those for PM2.5, and exposure to NO2 was the most lethal of the 5 pollutants that we are considering. We have a large variation or error due to the relative risk coefficient factors given in literature. In the annex, we can look at a few of the factors that have been used. When we look at respiratory mortality in Nicosia, we can see that the upper labels that are percentages of deaths of respiratory mortality rates simply for Nicosia. The bottom labels are the percentage of deaths as a percentage of Nicosia's population. These are metrics that we introduced in order to compare the effects of the different pollutants in Nicosia and in Limassol. Next, we are looking at cardiovascular mortality, and we have the percentages of NO2 and PM2.5, and we can see that once more NO2 exposure results in more deaths compared to PM2.5. Our final bars in both of the graphs labeled lockdown are a lockdown scenario where we have taken the lockdown average that we calculated over the 2.5-month period, and we have assumed that this is the concentration of NO2 and PM2.5 that we're going to have as the average for the entire year of 2020. And this results in a reduction in deaths. Furthermore, we are going to look at what concentration of PM2.5 we did have during the lockdown, and it was 12 micrograms per cubic meter, and it resulted in 42% less deaths per 100,000 inhabitants. The labels once more are showing percentages of cardiovascular deaths per Nicosia cardiovascular mortality rates. Those are the upper labels, and the lower labels are showing the cardiovascular deaths as a percentage of Nicosia's population. Looking at respiratory mortality in Limassol, we can see the population is increasing from 2012 to 2021. However, our deaths are falling over this time period, and we have also plotted the NO2 concentration, where we can see that the deaths also follow the trend of lower NO2 concentration. So we can see that on average 0.03% of Limassol's population has been affected by respiratory deaths from traffic emissions. We also have the darker blue label on the right, the darker blue charts on the right chart showing other deaths that are not respiratory. So total deaths less respiratory mortality. And then we can see that using the lockdown scenario, 20 lives were saved compared to 2021 deaths. We have the same for cardiovascular deaths in Limassol. We have an increased percentage of deaths in 2021. However, this is mostly due to other deaths. And then PM10 contributes slightly. However, NOx seems to be the bigger contributor, as well as NO2 for the cardiovascular mortality in Limassol. Once again, we see that the lockdown scenario does reduce the number of deaths. Looking at the pollutants in detail, we have NO2, NOx, and PM10 plotted alongside each other. And these are showing each pollutant's contribution to total respiratory mortality. And we can see that from NO2, about half of the deaths can be attributed to traffic emissions. For NOx, about 20% can be attributed to traffic emissions. And for PM10, about 15% can be contributed to traffic emissions in 2021. Here we're looking at ozone and SO2. Ozone generally has a lower risk, relative risk of exposure. This is due to how it's not as lethal as PM2.5. However, it was included in the study because it is a secondary pollutant. And given the increase in ozone over the years due to increased photochemical activity, due to increased temperatures, increased sunlight exposure, we are expecting greater deaths from ozone in the coming years. For SO2, deaths were low as well. However, this is expected to fall with time due to improving SO2 content in fuel, sulfur content in fuel. Then when we look at all of this data, we can look at the mitigation. And what we propose is, and it was interesting to see when I got an SMS the other day that motorcycles are now being invited to take MOTs, even though it has been in legislation for a number of years now, it was not enforced. So I'm happy to see that now MOTs will be having MOT inspections. And this is going to enable us to keep track of the real world emissions of VOCs and PM2.5 from motorcycles and mopeds. Given the increase in motorcycles that we saw at the beginning of the presentation, we also moved towards the electrification of motorbikes, and this will give us a net zero VOC, PM, all pollutants, all exhaust pollutants from the electric vehicles, and this should in turn reduce the emissions from secondary organic aerosols. This will also go towards reducing congestion and also phasing out heavy-duty vehicles and buses will also reduce these intermediate VOC concentrations that are effective and efficient at forming secondary organic aerosols in the atmosphere. We also look at proposing some incentives for replacing Euro 3 and older passenger vehicles. Euro 3 vehicles, Euro 2, Euro 1 and below are less likely to have catalysts, and these catalysts, they reduce the concentrations of NOx, they reduce the formation potentials of their exhausts in forming secondary organic aerosols. We also propose the reduction of the import of secondhand older cars into Cyprus. And we also look at a lock-in effect of buying less efficient cars, as this will, as we know in Cyprus, the average age of cars is 15 years. So buying an older car is going to lock in that car in the Cyprus fleet for perhaps 10 years. So we move towards buying more efficient Euro 6 vehicles. A disincentive would be to increase road tax on diesel passenger cars. I would like to conclude the presentation by acknowledging some of our colleagues from the Ministry of Transport, the Department of Labor, and also the Cyprus Institute for providing data. Thank you very much for your attention.
Thank you, Michelle.
Questions might be at the end of the...
Exactly. Questions
Okay.
will be posted later on. Now I pass the word to Anastasia. She is going to introduce the next invited speaker. Anastasia? Your mic is off.
Thank you, Cristina.
Thank you.
Yeah, so it is with pleasure, with great pleasure, I welcome here my good colleague and friend, Thanos Danielis. We've been known each other for quite a few years now. We first met in Germany in the Institute of Environmental Medicine in the Technical University of Munich, where Thanos used to work as a senior researcher. Nowadays, he's back in Greece. He's assistant professor in terrestrial ecology and climate change in the Department of Biology in the Aristotle University of Thessaloniki. He's a member of the European Aerobiology Society, where he currently serves as the secretary. He's also Europe Chancellor of the International Society of Biometeorology, a member of the EU MetNet Autopollen and Autopollen 2 group leader. And the list goes on. And instead of listing down, maybe it's best to pass the speech to Thanos so we can listen to him. Thanos.
Thanks a lot, Natasha. Thank you, everybody, again. Nice to meet you all. I guess also in Cyprus and many other places, it's also very hot. It's also very hot today in Greece. So it's really not easy to, work. But I'll do my best to not bore you too much. So the structure of my talk, I'll share my screen. I hope you see it soon. It would be kind of a compilation of some different projects, one of which is also COVID. You see it, right? You see my screen. And the title of my talk is Allergy and Environmental Disease. I will talk about the past, present, and future. You probably, all of you know that allergies are a kind of ongoing and increasing importance disease. Lately, they called it's an environmental disease, and also lately, a bit before the COVID, they unfortunately called it that it's the pandemic of the century. Still is, but of course, after the COVID, it's not as accurate anymore. But I would like to practically tell you a story. And since I'm an asthmatic, so I was also very excited to hear the results of Michelle, because that's really relevant for me, also being an asthmatic with allergic rhinitis since a child, and also allergic to pollen and many other things. So I will start with trying to show you what it means for those that don't know, what it feels or means being allergic/asthmatic. So practically, let's talk about the past. In the 70s and 80s, the allergic patients were hardly diagnosed. We didn't really know what is allergy or how we treat them, or we didn't treat them correctly. They didn't treat them. I'm not a medical doctor. So the treatment was still kind of not as developed as today. For this reason, also, we didn't know also the sensitization to many different allergens. Mostly they used crude extracts of mixtures of different allergens. And the main challenges were with basic skin prick tests. And regarding the exposure, practically we knew since the late 50s, if I remember correctly, of what we're exposed to, but the technology until today, interestingly, it's still using the same technology. So good news, we had measurements of what we're exposed to, but actually this is not real-time, not automated, very difficult to assess and so on. What happens nowadays? Let's go to present. So definitely both diagnosis but also treatment have improved. We have higher accuracy. We know about sensitization and especially multi-sensitization that can be easily evaluated with molecular tests and novel diagnostics. Exposure, unfortunately, is largely relying still on technology of the 50s, so similar devices. And usually, even though there are nowadays lots of data, most of them are privately owned or they are relying on private research by private, I mean, university-based and on our own funding-based research. For the above reasons, overall, the treatment of allergic patients has significantly improved, so it's more efficient. But we still have a huge gap on the exact exposure. Practically, we don't know, and especially we don't know real time, of how much we are exposed and to what and where and when. So if I continue saying the story from my eyes, now an adult, what happens if we add the variable of the environment into the treatment? If I want to go into clinical practice, what happens if I want to say, okay, since allergy is an environmental disease, we'll see about it in a while. What happens, and if I want to translate it, how the ongoing climate change can make us sick, as they say, and it's not me saying that. Actually, the latest report in 2022, I was honored to be part of it, of the IPCC. They categorized, maybe you know this already, they categorized and they said of what in the future humans we are going to be sick. And of course, they said that the number one reason of deaths, about 3.7 million per year, is non-communicable respiratory illnesses, among which, of course, these are allergies. And I will not get into details giving the background. I won't go to the main story. And it's well known actually since even the 80s or 90s that allergies, and not just allergies, but also asthma, allergic asthma, non-allergic asthma, pollen-induced or mold-induced allergies are increasing dramatically since the 80s, especially 90s, and during the last, of course, couple of decades. They have been published in many multi-center studies, and we know this throughout the world nowadays. And if I want to add one more, actually, factor, because somebody could say, okay, it's the environment, how and why. If I take into account another factor, practically, we have to consider the climate change, of course. We have to consider the environmental changes of any kind. We have also to consider that we have wars. Somebody could say we had wars always, unfortunately, but we have this increasing. And also we have a lot of migration. Could be climate change migration, could be financial migration because of the worldwide, of the European crisis the last 10 years, which means that we all of us have to readjust ourselves and our immune system to different environmental conditions, but also different health system, different medical services, different, of course, exposure, allergens, and so on, and also stress and many other things also related to our lifestyle, even our diet. So you see how complicated it does. And if I want to say, okay, what can we do? Let's start discussing about, yeah, we have a problem, but let's see what we can do about it. The easy and a bit political to say, and we get several times, a bit political, you'll excuse me about this, is the change of mindset. And why is that? We see here that actually that's what we do so far. That's perfectly fine because we try to involve in the equation of climate change plus human health as many factors as possible. Of course, it's not easy, it's very complicated, but you see already the previous speaker touched many of these things like VOCs, biogenic particles, also air quality of many different kinds. We have pathogens like COVID, SARS-CoV-2, and many others that usually we forget, even though they're so important, like stress. But there is a problem with this diagram. The problem is that actually the human is in the center, which even though we want to translate mostly into our own species well-being and health, practically we should see things more holistically in the One Health, let's call it, approach, and then see things in the frame of the environment, whatever this means, whatever is around us, also inside us, and also in combination with where we live, let's call it urban greenery or planning. This leads to ecosystemic services. Of course, the big aim for human health, at least, is personalized medicine, but this requires to know about environmental health, All these are an umbrella of climate change and so on. And in the end, it doesn't matter how I name that things change, because practically when we talk about a changing world, it's nothing else, especially for data-oriented sciences, about changing data. And since the data are changing, do we really know what's happening? And what we definitely know is that no matter what changes, it's our fault. It's not me saying that, this figure is from NASA. So we know that whatever is changing, let's talk about temperature here, but also human-induced changes or natural-induced changes. You can see in the two lines that are actually the human and natural or just observed temperature, that the increase after about the 90s is the big exponential, actually, peak of temperatures and whatever other drivers lead to that. And we see that it's practically, yeah, it's our fault. So that's well known. I don't think we have any people that are against this well-known fact. Don't mind the Greek. I'm sorry about the Greek. Here it's just to show, okay, let's say that the problem is that we don't know the accurate exposure or the multi-exposure, as I said before. So we need to calculate this. How do we calculate this? We have to measure it. The example of bioresources is a bit more complicated because we don't have the technology. We start having it. We don't have real time. We start having it and automation. For this reason, we might have a lot of years of data. As you see the numbers, let's forget about the Greek. In some sites in Greece, we have 33 years, like in Thessaloniki, and many others, we have just a few years. I'm referring mostly to Greece, not just because it's my hometown and my country, but also because Greece shows one of the most intense increasing long-term trends across the whole EU. So we know that we have more pollen year by year, decade by decade, and that's why also it's a nice case study to show Greece. So we need to measure the exposure of aerosols and know how and where. We need to know for the major allergens, here I saw pollen, of where, different columns, doesn't matter about the Greek, and how much on average per year increase in many different sites. We have something between 4.5 thousand and 15.5 thousand. You see the huge variation. On average, again, we get every year more than 40 different pollen types or taxa, as we say. And the main for a typical Mediterranean climate, including also Cyprus, Italy, Spain, Greece, and so on, is cypress pollen from Cupressaceae, as you see here. Olive, of course, pollen, which is a major allergen, and many others. But in terms of abundance, it's also Quercus oak pollen. And of course, we do care, if we talk about allergies, to know anything about everything about seasonality. So when we measure the exposure, we want also know the when we are going to be exposed, and when is also about the start. It's about the peak season. And in the Mediterranean, since we have these kinds of weather, we have a multi-exposure of many different allergens at the same time, which, for example, we don't have as intense, more to the Central or North Europe. And of course, we need to know the end and the duration, because we then know when it's safe, if I may call it like that, to be outdoors and have our normal life. And as I said before, for Greece, we knew actually since about start of 2000, so 20 years ago, after the first study that was done in Switzerland, we knew that actually we have dramatically increasing trends. And here, from now on, the structure will be that I will show some case studies, not just from Greece, and I will highlight the take-home message in each slide with red. So the interesting thing about this research was not just that we have more pollen, is that we had a dramatically increasing from twofold to fivefold. Unfortunately, nowadays it will be even up to tenfold. So it was exponential, and maybe it's hyper exponential nowadays. So the magnitude of effect was huge, and it still is. That's true not just for Greece anymore, but of course for many other sites. What we saw also, and if I stay in Poland, but also if I add the flowering of plants, we see that it's not, of course, just temperature. It's easy usually to say that we have climate change, and what is climate change? Temperature. It's not as simple as that. So we see also, as the previous speaker said, that there are many different factors affecting, which is very interesting, temperature, but also urbanization, also NO2 has a dramatic role. It has many aspects of plants and, of course, human health. And we saw that everything occurred earlier. And very interestingly, we saw this in two different studies, different years, different species, Germany and Greece, and we had exactly the same results with exactly the same factors affecting it. More temperature, more urbanization, more pollution, especially from NO2, earlier seasons, flowering seasons, and pollen season. And then in bigger studies, we saw that actually that's true for many different pollen types. And in actually across the world, not just Europe, we saw that we nowadays have more pollen earlier and not necessarily longer, as it's used to say, longer seasons, but definitely we have all the seasons shifted earlier that's why we have already allergic symptoms, the pollen allergic people, already from January in South Europe, instead of February and March some decades ago. And the question, of course, is, should we expect also more severe symptoms in pollen allergics? And if I may also take into account that some pollen types are allergenic, but they're not just simple plants, that could be invasive plants, like ambrosia and many others, and also some new ones, new allergens, emerging threats for human health. But let's stick to ambrosia, which is a well-known aeroallergen. It is a new allergen, new, of course, we know about it for something like 2 decades. It's also a new exposure. For example, we didn't have it in Greece. I assume, I don't know, also wasn't in Cyprus, but we do see it increase the last about 10 years, not in big quantities, but they are increasing constantly. And obviously that shows that actually we have a transition of this invasive plant and its pollen to other places, which means potentially new sensitizations and symptoms and new patients. And to get a bit more interesting, also, sometimes we assume that I am exposed to whatever I'm exposed locally. And I assume that if I have a plant, then the pollen should be from this plant because it's very close, it's within 10 meters or 100 meters, and that's what I should be afraid from, let's say, a park. But practically, when we did a study, flying literally with airplane, a small aircraft, Cessna, we assumed by the time that maybe we caught some pollen of fungal spores also, a bit higher up. And the interesting result, which was published in scientific reports about a decade ago, was that actually we caught the majority of the pollen and fungal spores at higher altitudes, very important, near the boundary layer, a bit more than 2,000 meters. And we saw that it was quite common, as we happily research for the research, of course, not for the human health. We saw a few years after we published that New York Times in the front page, they published a yellow cloud saying that we have extreme pollen blankets. And they have a sneezing also episode because of a yellow haze, which is caused by pollen. And practically, because of climate change, and we'll see in a while why, it could be that we have some extreme events. And for this reason, we have extreme and different unpredictable exposures, let's say to pollen, but also fungal spores. And this could be because of different temperatures, but also of different wind speeds, strongest from what we find in Greece, but also more thunderstorms, different seasonalities of specific factors like the thunderstorms. And this means practically that I'm not just exposed to an allergen that I was exposed in the past, but maybe I'm exposed to a combination of allergens and other factors like pollutants, as we said before, which means that practically if in the past I could treat quite well my patients, it's more unpredictable nowadays. And if I want to focus a bit more, since it's also a bit popular term about this famous thunderstorm asthma, unfortunately popular because of the unfortunate event in Melbourne 2016, 10 people died. They had within a few hours 3.4 thousand of emergency calls and hospitalizations because of a huge thunderstorm. After that, even before that a bit in the UK, but after that many other countries, of course, like Germany, Canada, Italy, and so on, they tried to study this new threat, if it is a new threat. But definitely we are not even close of understanding what's happening. There are, of course, some theories. I will not get into details. The important is that we need to assess this. We need to understand this environmental exposure. We need to have a combination of symptoms, of data. And this is medical information, which could be symptoms, allergic symptoms, well-characterized patients, their clear history, health status. Also, we need our biological data. So we need to know to what we are exposed regarding bioaerosols, and also weather, but also air quality generally, not just thunderstorms, but also as it seems, also air quality. And we saw, unfortunately, I don't show it here. Here, so the simple, of course, case that when we have more lightnings, we have also more grass pollen, and we have more asthma cases. As you see, the 3D graph goes more back to the corner, which means that we don't need only grass pollen, because that alone causes symptoms, and only lightnings, but the combination of these, let's call it thunderstorm asthma, leads to more asthma cases. What I don't show here, because that was a panel of graphs and it was more complicated, is that when I have additionally more NO2, more PM10 and PM2.5, then actually this explodes. And then suddenly, even if I'm not allergic to pollen, to the specific pollen, let's say grass pollen, I could still have an asthma case, which is very, very interesting. And that shows how important it is to know the multi-exposure of our environment, of what we're exposed to. And if I want to continue and give one more example from the IPCC, also from the latest report. Here, actually, the sow, which we see already in many places, regardless if it's floods or if it's precipitation that leads or not doesn't lead to floods, we see that what we see and we expect with two different scenarios, plus 1.5 degrees Celsius or 3 degrees Celsius, is that if we look at the down graphs, C and D, and especially if we look at the right, the bad scenario, which could be that's where we're going to, we see that it gets darker and darker over the years. So the scenario for the plus 3 Celsius degrees. And what we expect, if this is true, is that actually whenever it gets dark, it means we have more maximum daily amount of precipitation, which means more floods, potentially, indirectly, but also more thunderstorms. And this shows the potential increasing risk of the thunderstorm asthma, since I mentioned it just before. And even though I have been discussing so far about allergy and if it's environmental disease, I think that it's clear that it's affected by many different factors, environmental of many different types. Since it's kind of recent, allergy is an environmental disease, and we expect, as a matter of fact, that half of the global population will suffer from some kind of allergy by 2050. However, there are also other respiratory diseases, like the infectious diseases. The infectious disease, as you see in the graph to the right, is considered the #1 risk factor for human health over the forthcoming decades, also not just from this paper, but also from the IPCC predictions, followed by bacteria, but also many other factors. I mean, you see how big of a problem is pollen allergy, and you see how small, this is plants, in the end, it is when I compare it with viruses and bacteria. And you see also the factors that could lead to increases of bacterial infections or with viral infections. And let's talk a bit also about non-allergic respiratory diseases. Practically, the effect of viruses on viruses is not something really new. It's actually an old story, because actually we knew that pollen somehow interacts with viruses. It wasn't just clear how much and with what cofactors and under which conditions. So practically what changes now, that's why it becomes so popular, not just because of COVID, is that since we know that pollen seasons are shifted earlier, and as I said before, we have more pollen every year, practically what was in spring or late winter coincides nowadays with the virus season. And as we have more pollen, so practically have an additive co-exposure burden to the people that could have a viral infection and at the same time be exposed before or after or during with, let's say, the pollen season. So it's not just that we see it in COVID. So practically we have seen this in many different cases of viruses, RSV, HRV, different viruses in South Korea, in Italy, and many other places. I will not get into detail. We also studied the mechanism of how viruses could be contributing to have a higher risk of being infected by here the SARS-CoV-2 or other viruses. We tried also with RSV and also rhinovirus. And practically, and very simply, we know that actually the immune system kind of doesn't produce as many interferons that are normally in normal conditions can fight normal viruses like rhinovirus here. It was true also for SARS-CoV-2, and then a bit before the era of the COVID, we actually, and after we defined this mechanism that was true by the time, we actually saw that it happened across a big cohort of data about new cases of SARS-CoV-2, and also across 248 monitoring stations that we had measurements of data in 31 countries from all hemispheres. We did a big study of 154 authors that was published in PNAS, and with a strict approach, statistical, but also general analytical, applying the straw protocol, we actually did the combination of analysis so that we saw practically that we have more pollen, and when we have more pollen, we have also more cases of COVID-19. Very interestingly, the lowest cases of COVID-19 were when we had also the lowest cases, amounts of pollen. And I would like to go on then with another, I'm sorry I'm jumping from topic to topic, but I guess you get the meaning. And another one to show that actually allergic diseases or generally respiratory diseases could be relevant to environment, and I will finish soon, is also relevant to about our common ways in urban places of having urban green, right? I mean, all of us, we know that urban green is useful to us for our well-being, mental health, and so on. But we have also bad examples because not necessarily urban green is necessarily by default good. So for example, we have the bad urban planning example of the Green Olympics of Beijing in 2008. So when they were organized to be implemented in 2008, actually because they had a lot of air pollution in China, the organizers, long before the start, they had proudly announced that they intend to plant several thousands of trees to improve air quality so that athletes and all visitors don't have a problem with bad air quality by that time. Indeed, they started planting already in 2005, 1.5 thousand trees, but with no appropriate urban planning. And for this reason, they just selected, because they just didn't know, highly allergenic trees, mostly cypresses by the time, but also pines, which means that in the end, the 2008 Beijing Olympic Games were marked not only as being one of the most polluted by that time Olympic events up to today, actually, but also they had, of course, many cases of allergic elite athletes and also visitors, which was actually an added negative effect because of the meant well, but still bad urban planning in this case. So from all these case studies, practically we see that allergy is indeed an environmental disease. We see that things don't seem very optimistic for the future, but we do have a take-home message that practically we have a changing planet that makes us and potential our children get sick or not have the well-being that we would like to have. And on the other hand, we have a big challenge, us as a scientist and many of you maybe as clinicians, that we are more mature on the other hand to provide the technology, the tools, and also the expertise and the know-how of how we can treat things differently because we have a common enemy which is called climate change. And the actual enemy in the end is not climate change, but it's that we have to be fast because we don't have time. Maybe it's said already by many climate change scientists that actually it could be that some things are not reversible anymore. And that's why regarding human health, we don't have any time to lose. And the challenge is to deal with the changing times. And this can be done, to my opinion, only by integrating forces, uniting forces, integrating data, and trying our best together to deal with this big problem. And to do that, to be a bit more political, unfortunately, some decades ago, not very long ago, in the European Parliament, one Europarliamentarian, unfortunately, because they were not aware yet by the big menacing climate change problem, he said in the European Parliament, why should we care if the polar bear gets extinct? And of course, now we know why we should care about biodiversity and why we should care about species not getting extinct or shifting or changes of this huge magnitude. For bioresources, unfortunately, the big problem is that we don't have a central monitoring system in Europe, but also in other continents, everywhere actually. And even though we expect that half of the population in Europe could be allergic to some kind of bioresorb, we still until today haven't convinced the EU that they have a standard monitoring system funded centrally by the EU to provide this information to clinicians, but also everybody that is allergic or not. And for this reason, we have to integrate and persuade and make our best, as we did on the 4th of July 2023, visited the European Parliament, and we did a roundtable trying to show the importance of bioresources and showing the importance of allergies, and trying to show that we need in a One Health approach to actually address the allergy, but also asthma pandemic, as I called it in the beginning. And that's my take-home message, that by uniting forces and by being loud sometimes, especially to the decision makers and policy makers, I think we can manage to do our best. And I would like, of course, to thank a big team of all this project I showed. Some of these people are inside here in the meeting today. Thank you very much for inviting me, and I'm waiting for your discussion and questions.
Thank you. It is indeed, like I said in the beginning, we always learn a little bit more regarding these issues, and it was a pleasure to receiving you and Michelle in this webinar. So now we can begin our questions. Please, you feel free to raise your hand, virtual hand in this case, and you have the opportunity to ask anything to Professor Thanos and to Michelle?
Yes, Cristina, if I may,
Yes, of course.
a quick question to Thanos. Thanos, thank you for this. It was very concise and enlightening. So you showed us how climate change is going to affect temperature and then pollen seasons and then exposure and symptoms, etc. So would you like to elaborate a bit more on fungi? What is the situation there? What do we expect? Do we also have seasons there for the symptoms? What should we expect for the future?
I have two versions, a short one and a long one. The short one is that we have no idea. So the longer one is that we have an idea, but as I said, I guess several times during my talk, it's very complicated, and especially when you go to fungi or other allergens overall. For example, for pollen, it's widely known that it's earlier and more, which, by the way, is not true for all of them. So some of them, they don't care. They just don't change. For example, the hazel pollen, they don't care. It's not earlier. It's a bit earlier, maybe not significantly. It's not more. It doesn't change. Why it doesn't change? Personally, at least, I don't know. And that's true, as I said, in Germany, in Greece, in many other places. Hazel doesn't change. For fungi, it's even worse because fungi seem to have a different strategy towards climate change, which is good for them because they don't produce more, they don't shift, they don't become earlier and so on. But they do something different. Fungi, they need practically a substrate. They need food, let's say. So they need to grow on something. And the something could be many different things. Could be soil, could be also trees, could be plants. And they seem to not care producing more, which is good news for the allergics, but they seem to be faster because they have enzymes, that these enzymes actually are stronger, more aggressive. And they say, okay, I don't need to produce more spores, which is good news, no allergies, but I have to be faster in occupying more and more space, which in the end could be the same, more symptoms because they have more surface of fungal infections, but it's even more complicated. And also they have a bigger lag effect. The plants, for example, they have a few years, and the fungi can have more than a decade, which is good news again for the climate change because they're not stressed as much yet. But I would like to emphasize on the yet. So practically, we don't know what happens in another 10 years. So it's, as you see, it's quite complicated, but it's different from the plants, and that's interesting. And so,
Yeah,
Okay.
thank you.
Thank you. Now, Susanna, please.
Yes, thank you.
Thank you.
Thank you to both of our presenters. Nice work. I have a question for Thanos. I was wondering, I don't know if you mentioned, but I think I didn't see this. Did you have to make any bioaerosol sampling during dust storms, or are you aware of any more? I've seen a study like years ago that they looked into the different bioaerosols. So like dust events can be a phenomenon that transport also some of the bioaerosols. So I don't know if you have more insights on this.
so we have done a lot of work lately. Actually, we have submitted just now an event from Athens and Thessaloniki during such kind of events with a combination of LiDAR measurements and how we can maybe forecast the dust events, but also false from the LiDAR, false alarms, let's say alerts, that could be pollen and not other particles. Also, we have done some work in Germany, also high altitude. So what I saw with the airplane, imagine something similar with patients and symptoms, but at a high altitude site where we thought that the patients wouldn't have any symptoms because there was no vegetation. And we saw surprisingly that we have some incidents like 2-3 days in a row that we had trajectories coming actually across the Atlantic and potential sources, if I don't dare to say across the Atlantic, let's say it was Northwest France. And we saw they got even symptoms because of the far transported pollen. So we see it actually more and more often. And a third example, which is also a nice pass for Michelle, because I think it would make sense to collaborate. So lately we have installed the first station in Cyprus that measures bioaerosols. And we did that because a colleague of ours, they said, a pediatrician in Lemesos, he said that he has a very much increasing sensitization rate to fungus spores, which is above the average of the whole EU. And he suspects that it could be combined to cases of dust storms. And we are wondering whether I can see also aerosols coming in these dust storms and not just PM of any different kind. And that's something ongoing, and I'm very happy also with the whole team there in Cyprus if we can discuss and collaborate. So practically it's a kind of an uncharted territory, at least from the side of aerosols. But it's very, very interesting because we see that things are not as we thought they are. They can be coming from anywhere, literally from anywhere.
Thank you. Anyone wants to ask something to our
Yeah, I would
Iris?
like.
Okay, thank you.
Thank you for both speakers. Very interesting talks. I also have a question actually for Professor Thanos. So, because you said in a few decades, half of Europeans will have allergies, is that though because we are exposed to lower air quality, so we will become more susceptible to allergies? I didn't quite understand the link. Is there going to be a difference between Europeans living in urban areas and Europeans living in rural areas?
So, as in most things, when we talk about climate change, if you remember, and that's why the non-believers, let's call it like that, it was said that, for example, we expect the world to be collapsing, and that was like in 2000, let's say. Then they said now it's 2020. Now they say it's 2050. So the good news is that the planet is resilient. So that's one thing. The second thing is that also, to my opinion, is that these interactions are very complicated. As already, I think many of us know that we had the hygiene hypothesis, which said that it's nicer to be exposed to some factors, including, for example, allergens since younger age, because then this would make our immune system kind of protected. And of course, it's also about the changing environment, not just regarding biological stuff like bacteria, virus, and so on, but also the combination of them with the air quality. For example, when we did the study again in Germany by the time, we were checking, as I said, one example about high urbanization and more NO2, they cause to have more pollen. And what we saw is that this relationship was not marginally, but was not statistically significant. And what we found is that it's not actually that I get more pollen directly, but I get the plants infected with more plant viruses, and these, as a stress, increase the pollen, and then I have more pollen. So there wasn't a direct increase of pollen, but actually the viruses, together with NO2 and urbanization, led to the plants responding in a specific way, and then they produce more pollen. And that shows how complicated the system is, if I answered the question indirectly a bit.
Thank you. Anyone else wants to intervene?
Yeah, I just wanted to ask a question to Michelle. And I was very curious, how were you able to separate the death, the information about death of in the population regarding the different pollutants? You are muted.
Well, yes, you do not have sound in your mic. Yeah.
Okay, thank you, Edna, for your question. What we did was we applied the relative risk of exposure coefficient for the pollutants that we were studying. And in that way, we were able to apply the effect of a 10 microgram per cubic meter increase in each pollutant to the mortality rate. So the risk of exposure coefficients were already given for each pollutant type, and that's what we applied to the mortality data and the population data.
Okay, thank you.
Okay. So anyone else wants to intervene?
Yeah. I have one for Michelle as well, actually.
Okay, first
So-
Iris, then Kyriakos, okay?
Yeah, Kyriago, you have to let me speak first.
First lady.
So actually, this is a question I've had for a very long time, because there's lots of information now that there are actually lots of microplastics in the air, and we inhale a lot of microplastics. Do you see at some point the microplastics will also be included in the air pollutants? Because traditionally we have certain compounds that we mentioned, but we never mentioned microplastics. The question is for Michelle.
I actually haven't studied that or come across that. And it would be interesting to see, because with the electrification of vehicles, we're having more and more rubber and this type of pollutants in the air because of the heavier batteries that are causing more and more emissions from non-exhaust sources. So from brake dust, from the degradation of the tires. However, perhaps with the different materials that are used as more electric cars are made, it might be interesting to see how microplastics are being emitted from some of these new models.
Okay, thank you.
Thank you.
Kyriakos, please. You are muted. You must turn on your mic.
I have 3 questions for Michelle, and I have 1 question for all of you, actually. Very short. Michelle, are you there?
Yes, Kyriakos.
Hi there. You referred to a street called Spiros Kyprianou. Which one is that, please?
Okay, I will share my screen so that I can show it to you once more.
Please.
Okay. So that was
Yes,
at the
Thanos, you are
beginning.
next. Okay.
All right. So if we see this,
Okay,
the
thank you.
lowest
I got it.
horizontal line.
Yeah, it's the street I'm living on. Number 2.
Okay.
Not good.
Did you try to see the overall reduction in pollution during the COVID period, not just
Yes.
the one related to traffic?
Yes, we looked at, in addition to traffic, we looked at the reduction in the ambient air quality.
Uh-huh.
So in this presentation, I've included NOx and PM 2.5. However, we did do for all the pollutants that are measured at the traffic station that is right close to your street as well, Kyriakos. And there were reductions for all of the pollutants during the COVID period. 86% for NOx being the highest.
Okay. And the question for all of you, do you guys know which one is the most polluted country in Europe per capita? Based on the number of people living there.
Well, if it has to do with dust, I guess Nicosia, Kyriakos. But I suppose you're not referring to dust, right?
I am referring to all those sort of gases, CO2, etc. So Cyprus is by far the most polluted country per capita. The rest of Europe, these gases are decreasing. In Cyprus, they are going up. And it's quite an interesting finding that we don't really refer to all the time. We are in big trouble. That's it.
Yes.
You have a lot of work to do there then.
Yes, indeed.
Yes. So Thanos, please.
Actually, that was my question to Michelle, but since Kyriakos, nice to meet you, you brought this up. So I think also Thessaloniki goes well. So we are increasing SO2, funny, and also NO2. Even though NO2 was falling, we are very happy, obviously, to pay fines every day to the EU because we exceed the, the limits of NO2. Yeah, and it's interesting because we see differences because of NO2, as you saw in my results, to plants and also potentially symptoms. And I was wondering, when we checked also the coronavirus cases, but also many other with air quality, we saw that actually in our case, SO2 was significant. And Michelle, I guess in specific different, let's say, cities, if they had different air quality problems, I guess you would expect this, right? It's not, I mean, NO2 is a big factor anyway in all cases, I think. But I was, to be honest, until today, surprised that we have SO2 here. and we saw that it's very significant, even more significant than NO2. And I'm wondering if, since I'm not an expert in SO2 at all, whether it makes sense, whether SO2 indeed can be like that if you have high levels enough.
SO2 is also involved in secondary organic aerosol formation.
Mm-hmm.
So with perhaps some changes in meteorology conditions, for example, in high humidity,
Mm-hmm.
we have a lot of acids forming, some nitric acid, sulfuric acid, and this goes on to react and be oxidized in the atmosphere and form nitrates, sulfates. So
Mm-hmm.
perhaps from this angle, we could have an increase in sulfate. However, for SO2, I'm not sure how that how you record this increase in SO2 in Thessaloniki, given the general reductions from the improved vehicle technologies that we have now and the sulfur content in fuel that we have now.
It will be
Has
coming
to
from
do
different
with-
types of
Yes,
industry.
it's
Because,
domestic
because
heating
it's not really an
mostly.
increase, it's like a baseline change. So it kind of was going down, 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 and then suddenly something happened, and then just, went up and stays up. And I was
So
wondering whether
for
some
us, yes,
industries
Thanos.
were
Yeah,
installed.
sorry.
Yeah, I was wondering if something happened, which I don't know, like some new industries in the city that just produce. I have no idea.
Okay, we recently were trying to calibrate a device here at the university, and our measurements were so far off, including our SO2 measurements. And we were told that this could be from interactions with other pollutants. So SO2 was said to be very closely related with NO2 and chlorine, and that increases in chlorine would show an increase in SO2 as well. So perhaps there are some industries, like you say, that are increasing not only SO2 emissions, but also chlorine.
Okay.
No, it is actually, if I may interrupt officially this time. So in Greece, the situation has to do with the financial crisis in 2008. After that, because people had to turn to different ways for domestic heating. So most of SO2 in Thessaloniki or Athens has to do with that.
Even though we saw peaks that were also in winter, but especially spring.
Mm-hmm.
So
winter makes sense. Spring could be like
so after
secondary
spring, it fell down.
reactions.
Yeah. Interesting. Yeah.
If it was a peak during spring, could it be a transboundary or regional SO2? Because this is when we have those dust storms as well. And we have a lot of the air masses coming from the Sahara, from the Levant region.
Okay.
Okay.
Yeah, the take-home message is we have to collaborate. Let's stick to that.
This is a good way, like I said before, we are always learning, and with these small meetings, but very relevant meetings, there is something to learn. There is something for us to be able to think about and to research. And I think these indeed are good places for us to do a little bit of brainstorm regarding these issues.
Can I ask one? I'm sorry. Can I ask one more question, please?
Yes, of course.
And that goes to Michelle. Michelle, how much of the pollution in Cyprus is imported from the neighborhood, either from Turkey or Lebanon, Syria, Israel, or in the south, Libya and Egypt? Do we have an estimate? Because at some point, the department that is responsible for the air quality in Cyprus was making a big fuss about most of this pollution coming from Africa, North Africa.
Okay.
about 5-10 years ago. And Edna and I were involved in a project at that time, and that was their main point.
Together with
Okay.
Anastasia.
With correct, and some other people. Correct, correct.
From this study that we just looked at, looking at data from March to May during the COVID lockdown, and looking at those peaks in PM 2.5 and PM 10, these peaks did correspond to desert dust storms, as we saw from the high-split model. However, they accounted for only 5% during this 2.5 month period. They accounted for only 5% of the PM 2.5 that we did have in this time. And considering that during this lockdown period, there was a reduction in emission from other sources and other industrial sectors, it would be interesting to maybe look at a longer period.
Can I add? Sorry for jumping in, because I'm jumping in because we did a study like some years ago where we actually did some analysis on PM to identify sources. So yes, it's important for the government or the air quality section to justify the exceedances in the daily values. And yes, there is a significant contribution from dust events. We have a pretty frequent phenomenon. Even some of times we may not realize there is dust, but there is almost 1/3 of the time during the year, there's some contribution from Africa and the Middle East. But besides that, when we did PM 2.5 and we did some elemental analysis and source apportionment, actually transported pollution from the more southwest or north from side of Cyprus was pretty significant. I can't remember the exact contribution, but at least 30 to 40% was the major basically source of PM 2.5. So we do have a lot of transport and transboundary pollution. And of course, traffic and biomass burning was also other significant, but answering that whether there is a lot of transboundary, yes, we do.
Sorry, I was talking, but my microphone was muted. So I want to thank you all for being here and for the interesting communications of our invited guests. And I hope to see you all in a few days, in 2 weeks from now, in the 6th webinar on the 26th. I think it will be also very interesting for our project, but not only for our project, but for our personal growth. So thank you all for being here. Thank you.
Thank you all.
Good afternoon. Kalispera. Kalispera.
Yes.
Thank you. Oh, Bruno, sorry. Applause. Okay, okay. I saw hands. Okay, thank you. Bye.
Bye-bye.
Bye-bye, Michelle. Thank you very much. Olá, Flávio. Boa tarde. Obrigadinha. Olha, eu entretanto vou ligar-te. Vou ligar-te, ok? Mas eu estou a gravar a sessão, depois falamos, está bem?
Está bem, está bem.
Deus, beijinho, Deus.
Beijinho, tchau.